One of the most important things in technical drawing is the ability to visualize three-dimensional objects from different viewpoints. This is a skill that's needed not only in manual drawing, drafting, but also once you master this on paper, it makes it a lot easier when you go to use a computer-aided design system. In this particular demonstration, we're going to see how to visualize something from three particular viewpoints: the front, the top, and the right side. In this example, we have the front color-coded as blue, the top color-coded as red, and the right side color-coded as yellow. If you remember one of our earlier surface development drawings, SD8, it was color-coded for your convenience to help visualize how this thing should be drawn, cut out, and assembled. And again, we use the same color representation scheme. The front and back were blue, the top and bottom were red, and the right and left were yellow. I've created this drawing in AutoCAD in true 3D form to help with this demonstration. So if we look at this thing, right now we're seeing a three-dimensional view of it, but if I click into my 3D mode, you'll see we have what's called a little view cube that will help us manipulate this object around. So let's say we look at just the front view. So I'm going to click on the front in the view cube, and we can see just the outline of the front view as if you were looking straight on at it. Of course, if you were actually holding this thing, with your vision through your eyes, you of course may be able to see a little bit around the side or a little bit on the top. But theoretically, for orthographic projection, we're looking at this thing dead straight on, so you don't see any of the other edges, just the particular view that we're looking at, in this case the front view. Let's go back to our 3D view, and let's click on the right side of the view cube this time. And you can see what this thing would look like looking at it straight on from the right side. And then the same option we can do from the top. Again, we're looking at this dead straight on, so you don't see any of the other edges around, the lines that we're seeing in the top view. So now let's look at this, rotating it in 3D a little bit slower. So if we go to the top view here, I can take and just drag this up a little bit, and you can see how the front view evolves until you're looking at it dead straight on. Same thing with the right side view. I drag this down a little bit, you can see the top red edges slowly appear. So we're looking at dead straight on. Let's do that from the front view also. So I hope you're getting a little idea of how these views look once you're looking at them straight on. That the edge that separates this little step down in the top view is just shown as a line. Okay? Again, let's look at that. So if we're rotating this down and around, we see this edge right now as it comes into play, and as soon as we have it perfectly straight, all you see the edge is a line. You see that edge as a line. Same thing with the side view. As we rotate this thing around, get it straight. There we go. You can just see the yellow. And again, this little edge right here that separates the step, when you're looking at it dead straight on from the right side, just appears as a line. Alright, let's look how these different views would be drawn and laid out on paper. First of all, it's important they go in a specific order, that the top view is directly above the front view, and the right side view is directly to the right of the front view. Also notice how these views line up perfectly, that the edge of the front view lines up with the edge of the top view. And also notice how the edges of the front view line up with the edge of the side view. Okay, that's very important. Also, in this example, I have laid out some theoretical dimensions to give you an idea of how we are determining the length, width, and height of an object. And some of you had questions when we were doing a previous project, what represented the height, length, and width, and of course it depends on the orientation of how you're drawing something. But in most cases we're talking about the length being shown in the front and top view, the width being shown in both the side and the top view, and the height being shown in both the front and the side view. Okay, so if this thing was an inch wide in the top view, it should be an inch wide in the side. If it were 2 inches tall in the front, it should also be 2 inches tall on the side. And if it were, say, 4 inches long in the top, it should be the same in the front view. Again, when we draw these, if we line these things up perfectly, everything should work out accurately.